Hi class. Today we're going to clean up this code a little bit. I was thinking this is just way too cumbersome, and then we're going to try to make our computer a little bit smarter. So to clean up the code first, I'm going to say we're going to make a function called 3 in a row. And it's going to take 3 values, and those are going to be the indexes that we're searching for. Then what we're going to do is we're going to say if document get element squares A, B, A, and C. So if A were 0 and B were 1 and C were 2, we would have the same thing that we have down here. And if that's true, we're going to return true. Otherwise, we're going to return false. So as we're writing code, we should always be thinking, can I make this better? And this definitely there's a way to do it better, just to make the code cleaner. And then we can just delete all of that and say 3 in a row, parenthesis, 0, 1, 2. And then we can do 3 in a row, 3, 4, this is 3, 4, and 5. And do 6, 7, 8. Zero, 4, 8. 2, 4, 6. And if you notice, I don't care. I'm not thinking now. I know that 3 in a row is going to handle everything for me. So I just say, okay, what am I putting in for A, B, and C? And this is 0, 3, 6. This is 1, 4, and 7. It's still a little cumbersome, and there are things we could do to make it less so, but this is a big step, 2, 5, 8. I'll make it a little bit better. Okay. Yeah, so we can say if this is true or this is true. So we're going to do that as well. So then we're going to say or 3, 4, 5. So the double bar means or. Just trying to line these 3 up. And so we're going to go through all of these and say the first one or the second one or the third, fourth, fifth. So the next one was 6, 7, 8. And again, those double bars are saying if this is true or if this is true. So if any of these are true, it's going to declare a winner. 0, 4, 8, 2, 4, 6. Let's see what else is there. 0, 3, 6. 1, 4, 7, 2, 5, 8. And there's other things we could do as well. And now I'm just so you don't have an or at the end, because once you're done asking this or this or this or this or this or this, you don't say or and then leave it blank. You just end it. And then we have to make sure there's a double parenthesis here to close this first. And now we can delete all of these other if statements because they're all handled, and this should work. And now winner, I think that's acceptable. I think the other one was unacceptably long. I'm going to test it again. everything's working, so I didn't make any typos while doing that. So now what we're going to do is we're going to have the computer make a move. So we're just going to write a function, computer move. And our smart AI, the computer's just going to go in the first square that it finds. No, it's going to go into the first random square that it finds. So we're going to say if current turn is equal to computer turn. And we're going to have to define what computer turn is. So we have a current turn, it's X's and O's. And then we're going to make another one, call it computer turn. We're going to, right now we'll make it an O. But if we just change this to an X, then it's an X. And we'll be able to change that on the web page later. But right now we're going to say the computer's turn is 0. So if current turn is computer turn, we're going to, there's a random function. It's called math.random. And that's how, that gives us a random number between 0 and 1. And so we'll say our var r equals math.random. And then we're going to say r equals r times 8. I'm going to say math.floor. R times 8. And that's going to make it so the computer is trying to go, if r is a number between 0 and 1, when you multiply that, I'm going to do r times 9. If you get point, if you get 0.5, 0.5 times 9 would equal 4.5. And floor says round it down, so that would equal square 4. If you get 0.2, 0.2 times 9 is equal to 1.8. And when that is rounded down, you get 1. And if you go through all of these, if you get 0.99 times 9, you're going to get like 8.9 blah blah blah, which is going to round down to 8. And our squares have to be between 0 and 8, so this is giving us the ability to get the numbers from 0 to 8. R will never be 1 because it's not inclusive, so the number can be 0 up to like 0.9999999. So and 1 not inclusive. And then the computer's just going to try to go in that square. And so the way that works is we're going to say square clicked. And it's not even going to check is this allowed, because our board's not going to let it make an illegal move. So we're going to say square clicked R. And that's all we need to do. And it says if it's a valid move, return false, return, it just returns. Now, what do we want to do here? We want to call a computer move. Let's just check where we want to call it. So we have valid moves, telling us if it's a valid move or not. We have square clicked. We have switch turns. So whenever a square is clicked, we'd like to say computer move. And then what we're going to do, I'm going to say return false if it's not a valid move. And then if it is a valid move, we're going to return true. Now in here, no, actually we don't even have to do that. I'm sorry. What we're going to do is we're going to say, instead of if, we're going to say this is while. So while is just like an if statement. It will do the stuff in between here, but it's going to keep doing this until this is not true. So if the computer tries to go somewhere that's not a legal move, it's not going to switch turns, because when you say square clicked is going to say, nope, that doesn't work. So it's just going to stay there. Now, if there are no legal moves, then this is going to go forever. If it's an O, who would go last? Is there always going to be a move for O? Let me just check. So X, let's refresh this page. X, O, X, O, X, O, X. I won. O, X. So we're gonna actually let the computer go first to avoid it ever being in a position where it can go forever. We'll deal with it not being stuck there forever later. And so then what we're going to do is we're going to call computer move, and computer, like every time you click on a square. So square clicked, if valid move, right after we switch our turns. So when you click on a square, it's going to check if it's a valid move, it's going to make the move, it's going to check for a winner, then it's going to switch turns, and then the computer goes. And we're going to also, now what we are going to do in winner, where's winner? If we find a winner, we're actually going to say true. So it's not just going to display it, and if we don't find a winner, we're going to return false. And actually with that, that's going to avoid our loop. So we're going to say if beginning of our while loop, we're going to say if there's a winner, it's not going to move. We're just going to leave. And we're also going to ask that for square clicked. So if it's not a valid move, leave. If the game is over, leave. So you actually won't be able to click after the game is over. So making the game just a little smarter. So X. Oh, and then we are going to make it back to O because we have nothing triggering this to go first. We could fix that later, but right now I'd be happy to just say computer turn is O. And then let's refresh. And we will have a computer that basically goes in random squares. And now we have a winner. And once we have a winner, it won't let you move. And actually, I'm going to do one last thing. I don't like that it keeps popping up winner. And that's actually a design thing. You could keep telling the person there's a winner. That's why there's no move. But I'm going to check if it's a winner first. If it's a winner, oh, actually, wait, no. No, it's going to have that alert in this iteration. So we are playing. You could actually lose to the computer if the computer gets lucky. And the computer just beat us. Boom, 3 in a row. So not a smart computer, but a computer that's making moves, and then you can't make moves after the game is over. If you do that, there's already a winner. It's 3 in a row. Thank you. Hope you enjoyed this.